So what you just made was a, come on now, get off of there. There you go. What you just made was a parabola. Okay, you just folded yourself a parabola. Okay? The definition of a parabola is the set of all points equidistant from a point called the focus. Okay, now I'm going to borrow this for a second. Okay, the point that's called the focus is this dot, the dot that I had you make. That's the focus. Okay, and a line called the directrix. That's this line that I had you make. Label those on your graph. Or on your folded piece of paper, if you will. Okay. Your focus will always, 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 always be inside your parabola. Your directrix will always, always, always be outside your parabola. Okay? So the focus is a point located inside the parabola on the axis of symmetry. The directrix is a line located outside the parabola, and it's perpendicular to your axis of symmetry. Okay? What we're going to do today, okay, is we're going to give you the basic parts of a parabola. Okay? Then, over the weekend, you're going to do a flipped video about graphing parabolas and intro to ellipses. You have to do those before we get to the next class. So before you have class on Monday or Tuesday, those videos, and you need to take notes on them. It's not just sit and watch. It's sit, take notes. That is in lieu of us sitting and getting in a class on Monday or Tuesday. The reason you don't have class on Monday or Tuesday is because we're doing those flip videos. Okay? So those are, you need to take notes on those, and you need to do that before your 4-mod class. Okay? So we got that going on. Okay? So, real-world examples of parabolas. Okay? If you've ever seen a solar cooking pot, in the last class they told me apparently you did that at the school forest at some point in time in your school forest career if you came through the Wausau School District. Okay? All right? So the solar cooking pot, you put the pot at the focus of your parabola. Okay? And because what happens then is all of the sun or all of the solar energy comes into the parabola and it gets directed to the focus. Okay? So that's an example of a real-world parabola. If you've ever seen a parabolic microphone on a sideline of a football game, usually they have them on there. Sometimes they have them in baseball games, but usually you see them on the sidelines of football games. Okay? So that person, this guy right here, is holding this microphone, and he can point it at somebody that's 60 yards away from him, and he can hear what they're saying because the microphone for this is at the focus. So it's taking all that sound that's going in all directions, and when it comes towards him, it gets focused in, so you can hear things at a great distance. We are going to be talking about different parts of the parabola today. Okay? The first part that we need to talk about is something called the p-value. The p-value is the distance from the focus to the vertex. Also the distance from the vertex to the directrix. So on my graph, or on my picture that I made, the focus is up here. So this distance right here is P. This distance also is P. Okay? So it's the distance from the focus, which is the green dot up on the smartboard, to the vertex, which is the red dot, and from the red dot to the blue line, which is the directrix. Okay? Those are P values. Okay? Now, you've done extensive work with parabolas in Algebra 2. Okay? We are going to expand that knowledge here in pre-calc. So you've done vertical parabolas, up and down. We're going to expand it to left and right also. Okay? All right? So, we're going to give you the basic steps to graphing a parabola. And then on the flip video, we're going to actually graph some parabolas. And then on the last example on the flip video and one of the stations on Monday, Tuesday will be about making the equation of a parabola from the given information. Okay? So the very first thing that you have to decide is you have to decide which way your parabola is going to open. You got 4 choices: up, down, left, or right. So this is where your left is. Your right. Okay? All right? So you got up, down, left, right is your 4 choices. Okay? The first thing you're going to look at is you're going to look at which variable is squared. Okay? If x is squared, it's going to be an up or a down parabola. Those are the ones that you've seen before. If y is squared, that's going to be these new ones, these left or these right ones. Okay? Or new for some people. Okay? The second thing you're going to look at to tell you which way it opens is you're going to look at the coefficient on the non-squared variable. Okay? And if that coefficient is positive, then it's going to open in the positive direction. So if it's an up-down parabola, it would open up. If it's a left-right parabola, it would open right. Okay? If that non-squared coefficient is negative, then it would open in the negative direction, down or left. So here on this first one, x is squared. My coefficient is positive, so it opens up. On this one, x is squared. My coefficient is negative, so it opens down. Y is squared. My coefficient is positive, so it opens right. Y is squared. My coefficient is negative. It opens left. Okay. So that's the first thing. You got to figure out which way this thing's going. Up, down, left, right. Second thing you're going to do is you're going to identify the vertex. Okay? Now remember, when we're inside a set of parentheses, we think oppositely. So the first thing is, this here is the standard form for an up or a down parabola. Okay? X minus h quantity squared equals plus or minus 4p times the quantity y minus k. Okay? So this is up, down because x is squared. If this 4p number is positive, it would be up. If this 4p number is negative, it would be down. Okay? On this side, the standard form, this is the standard form for a left or a right parabola. Y is squared. If 4p is positive, it opens to the right. If 4p is negative, it opens to the left. Okay? In either case, the vertex is at the point h, comma, k. Just like with circles. Just like with circles. It's at the point h, comma, k. H is attached to the x, k is attached to the y. Okay? So in this first one here, I would look at, here is my number, and here is my number. Whatever's being added or subtracted to the x or the y term. Okay? I look to make sure it's in the proper form, meaning I've factored out that coefficient on the non-squared term. I have the squared term all by itself, so I have it in my proper form. I think oppositely because they're both inside a set of parentheses, so the vertex here would be at positive 3, comma, negative 1. Because they're both inside, I think opposite. Okay? Where do you think the vertex is in the middle one? What are we thinking for a vertex in this middle one? One comma 0? Agree with 1 comma 0. Okay? There's nothing being added or subtracted to the y, so that makes that one be 0. So the vertex here would be at 1 comma 0. Okay? Vertex on the third one. Vertex on the third one. What are we thinking? Oops, that won't go. So the vertex down here on this one is at -2, comma, -7. Okay? Side note, it's okay to be wrong. Okay? You learn from your mistakes. Okay? All right? Again, why is it called Formula 409? Okay? Because they screwed up 408 times making it. Okay? Okay? The third thing that you're going to do is you're going to identify the p-value. The reason that you need the p-value is because it's the distance from the vertex to the focus. It's also the distance from the vertex to the directrix. So we need that value. We find that value here as the coefficient that we factored out on the non-squared term. Okay? That's where we find that value. And this value is equal to 4p. Now, because p is a distance, I am not concerned with the negativeness of the negative 12. I'm only worried about the fact that 4p is equal to 12, so p is equal to 3. P is a distance, so it needs to be positive. Okay? All right, so let's cycle back through our first step. Okay? Our first step asked, what is the direction of opening of this particular parabola? Which way is it going to open? What's squared? X, so that's up or down, right? Is P positive or negative? Negative, so that makes it down, right? Okay, so it's going to open down. Step 2 said find the vertex. What's the vertex of this one? Three comma negative 1. 1, 2, and 3, negative 1. So there is my vertex. Agree? Okay. We just found that P is 3. Since P is 3, that means that my focus, because it opens down, my focus is down 3 from my vertex. So that's the point, 3, comma, negative 4. Because P is 3, that means that my directrix is up 3, 1, 2, and 3 from my vertex. That's the line y equals 2. Agree? Okay. Next thing, we're going to identify the width of our parabola. So this number here is 4p. That is my width of the parabola through the focus. So my parabola is 12 units wide through the focus. So that means I'm going to go 6 to the right and 6 to the left through the focus. Okay, so let me go back to it. 6 to the right, 6 to the left through the focus. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So my parabola goes through those 2 points. Which now, that allows me to draw in my parabola. Okay. So this distance, this whole distance here, was 12. Okay. The last step to graphing a parabola is you finish by putting on your axis of symmetry. And your axis of symmetry cuts the parabola in half. It's the line through the vertex and the focus. It's perpendicular to the directrix. So let me go back to it here. So the line through the focus and the vertex, we'll put it in purple, is this line right there, which was step number 5, which was the axis of symmetry, that's x equals 3. And that, ladies and gentlemen, is the steps to graphing a parabola.